Hello, I am Prathamesh Adam. In previous video, we are analyze and design the G plus 22 story building for a combination of dead load, live load, and wind load and seismic load. And we also designed the seismic resistance building by response spectrum method and diameter analysis. In this video, we are designing for that G plus 22 story building, designing foundation for that building. This is a problem statement. The building has 16 columns and these columns are spaced by 6 meter each, and the shape bearing capacity is given 300 kN per meter square and allowable settlement is 1 centimeter. We calculated subgrade modulus from the given data is shape bearing capacity divided by allowable settlement, and the subgrade is found out 3 into 10 raised to 4 kN per meter cube. And these are the values we are obtained from ETABS software analysis. These are the column size, column names, dimensions of column, dead load, live load, and material used for this column, design and analysis. And we are considering column strip 0.25 L1 or L2. L1 L2 is 18 meter for this problem, and the strip width is 4.5 meter comes out. We are considering 4 meter strip width. First of all, open the new file, new model, and set the preliminary settings and click on grid only option. The size of mat slab for our problem statement is 18 meter by 18 meter, and we required 19 grid slab. We are considering grid spacing is 1 meter. Now click on OK. This is the mat slab grid line shown here. Now first of all, we have to define the properties, material properties. We are defining material as M40 concrete. We are also defined rebar as HYSD 500 steel. Click on OK. Now we have to define slab property. We are defining the slab property for M40 grade concrete, and we are assuming the slab thickness is 500 mm. Now we have to define soil subgrade property. We enter the subgrade modulus. We calculate a preliminary 3 into 10 raised to 4 kN per meter cube. Click on OK. Now we have to define the column property. Click on add new property. We have defined both column properties. Column 1 is 500 by 500 mm and column 2 is 600 by 600 mm. Click on OK. Now we have to draw the mat slab. Click on draw slab areas. This is the slab we are drawn. Now we are extending 1 meter on each side on 4 sides of the mat slab. We are extended 1 meter on each sides of 4 sides. Now we have to draw the columns at location. Here set the column property below none, and property above is column 1, and here 0, and height above is 2 meter. Now we are drawing the columns. We see these are the column 1 of size 500 by 500, and this now we are drawing column 2 of 600 by 600 mm. We have drawn the 600 by 600 mm column, this center column, 4 columns. Now we have to draw the design strips. Here the design strips enter the 4 meter. All design strip width are 4 meter. We have to draw design strip in x direction 4, 1, 2, 3, 4, and in y direction also 4 design strip we have to draw. We are drawn the design strip. You can see. Now we have to assign the soil properties. Click on assign. We are assigned the soil 1 properties on this mat slab. Automatically this will assign column also. Now we have to change the design in the rebar material 500. Click on OK. This will require to do with all the strips and all the strips in vertical and horizontal direction. After assigning the steel material for all the strips and slab, we have to assign the loads on each columns as per given in the problem, or we are received the files on ETABS analysis and design G+22 story building. These are the loads we are obtained from ETABS analysis and design software. We have to assign these loads on that columns. For assigning, click on column center, verify one point is selected, and click on assign. Click on load data, click on point load, enter here the value dead, and enter the value given by, and enter the dimensions of column and click on OK. Now we are assigned all the loads on the column. Now we have to analyze this model. After analyzing, it will get these are the displacements in mm. The color will show the magnitude of displacement in mm here bar. Now we click on run analysis and design. Now click on display, click on show punching shear design. These all the values are greater than 1, means these are all footings are failing to receive the load on column, because it is the ratio of stress transmitted to the footing to its capacity, means it all requires to this value requires to come below than 1 for safer side. Hence we have to increase the depth of the mat footing. Now we will increase the depth from 500 mm to 1200 mm. See what happens. These all punching shear values is less than 1, hence it is all footings are safe. We can see the slab forces and stresses for load case dead load, or for combination we are see maximum bending moment. Click on apply. Here's the maximum bending moment. We also see the maximum shear forces for combination 1 or for combination 2. Now go for run detailing. Click on 3, click on OK. This is the detailing diagram of our mat footing. Click on drawing component view, click on slab view, click on framing plan, click on rebar plan. This is the rebar plans. This is the top rebar plan, and this is the bottom rebar plan. You all see here. This is a section. Here is a section of our mat foundation. This is a reinforcement profile for mat foundation. Maximum and minimum reinforcement profile of our mat foundation design. This is a reinforcement profile for strip B in Y direction. You also see this is 3D extrude view of our model or mat foundation footings design. These are the strip forces. We also see the cracks in the footing for all combination apply. These are the cracks, crack width. These are the values according to their colors. This is the rebar schedule of our mat foundation design. This is the rebar table. This is completed of G+22 story building footing design on SAFE software. Thank you.